In this video, we'll take a look at something called specific solutions. So if you ever wonder how to find that plus c from the general solution, what has to happen is you need to have coordinates of a point. So if we want to find the general solution of f prime of x is equal to 2x minus 2, that means the derivative of our function is 2x minus 2, and then find the particular solution that satisfies an initial condition. An initial condition, f of 1 is equal to 2, gives us a point on our function. So if we're given the derivative, f prime or dy dx is equal to 2x minus 2, then take the integral to find then y is equal to the integral of 2x minus 2 dx. So when we take the integral of 2x, we get x squared. The integral of negative 2 is negative 2x plus c. So our general solution of the antiderivative, or the integral, is x squared minus 2x plus c. So off to the right, these are all of the possible graphs of the parabola x squared minus 2x plus c. And remember that when you're adding or subtracting a value, it moves your graph up or down. So if we're given the initial condition, that means we're given f of 1 equals 2. That means we're given a coordinate on the graph. So to find c, the particular solution, substitute x equals 1 and substitute f of x is equal to 2. So we get 2 is equal to 1 squared minus 2 times 1 plus c, and solve for c. We get c is equal to 3. So the particular solution that has the coordinate 1, 2 is f of x is equal to x squared minus 2x plus 3. So when you take the indefinite integral, you have a constant of integration. You can find that constant if you know one point on the graph. So let's practice. We're shown a family of graphs, each of which is a general solution of the given differential equation. Differential equation means the derivative. Find the equation of the particular solution that passes through the indicated point. So if the derivative dy dx is equal to negative 5x minus 2, then what we're looking for, I'll write this out, negative 5x minus 2 times times multiply both sides by dx. We're looking for the integral of negative 5x minus 2 dx. Find the integral by using the power rule backwards. The integral of negative 5x is negative 5, add 1 to the power, x squared over 2, minus 2x plus an arbitrary constant. So our derivative, capital F of x, is, the derivative of our function is our integral. So our original function is negative 5 halves x squared minus 2x plus c. To find out what c is, take our coordinate 0, 2, let x equal 0, let the y coordinate, or f of x, equal 2, and solve. So if I put a 2 in, I get 2 is equal to negative 5 halves times 0 squared minus 2 times 0 plus c. 0 cancels everything out. C is equal to 2. So my specific particular function is negative 5 halves x squared minus 2x plus c is equal to 2, so plus 2. So the particular solution to the graph that's bolded with the coordinate 0, 2 is this function. One more example. Find the equation of the function f whose graph passes through the point. So if the derivative of my function is 6 over x squared, then I'm trying to find my function by taking the integral of 6 over x squared with respect to x. Remember that we have to write that as 6x to the power of negative 2 so we can apply the power rule, dx. So the integral would be 6 times x to the negative 2 plus 1, which is negative 1, over negative 1 plus an arbitrary constant. So our function, I'm going to put my capital F here. So the function f of x is equal to negative 6 over x plus the constant. So that's the family of functions. If it goes through the point 2, 5, then let 5 equal f of x equals negative 6 over x is 2 plus the constant. 5 is equal to negative 3 plus c, add 3 to both sides. My constant is equal to 8, so my specific particular function that goes through that point is negative 6 over x plus 8. So that's how to find particular functions. If you find the integral and also have a point, then you can find the arbitrary constant now will be the constant for one particular function.